So one way we can use the solubility product constant is by determining if ions can precipitate out of solution. So the way that we do that is we use the reaction quotient to determine if it's going to precipitate. We use the Q, which we've already studied. And so for here, if your reaction quotient is larger than your KSP, what that means is that precipitation is going to occur, and it's going to occur until your Q equals KSP. Well, this makes sense because if your Q is larger than your KSP, that means that the amount of product you have is too high, and therefore you want more reactant to form. Well, keep in mind your dissociation equation, your reactants are the solids. So if you're forming more reactants because your Q is too large, that means you're going to form a solid. And so precipitation will occur, the formation of a solid. Now, if your Q equals your KSP, that means you have a saturated solution and you're not going to have any precipitation occur. If your Q is less than your KSP, what that means is that your products are not your reaction needs to proceed to the right, and therefore your solid is going to dissolve, because remember, your products are going to be your ions in solution. And so no precipitate will occur, and instead more of your solid will dissolve. So let's look at an example here. Here it asks you if a precipitate forms if you have a specific amount of sodium fluoride and a specific amount of calcium nitrate mixed together. And so your first task is to identify what ionic solid could precipitate out. Now keep in mind any compound with a group 1 metal like sodium or any compound with nitrate are not going to form solids. They're always soluble. So the only two ions that could form a precipitate would be calcium and fluoride. And so what I'm going to do is I'm going to write the dissociation equation for calcium fluoride. So calcium fluoride will break apart into calcium ions and fluoride ions. And so now what I can do is I can use the concentrations of each of the ions that I'm given in order to calculate my Q, my reaction quotient. Here's the only issue. If you look here, I'm given a certain volume of sodium fluoride and its concentration, and then a specific volume of calcium nitrate and its concentration. However, when you mix these solutions together, that alters the concentration. So here's what I need to do. I need to take sodium fluoride's concentration and multiply it by its volume. That way I get the number of moles. Once I have the number of moles, I can divide by the total volume, which will be the 0.05 liters plus the 0.010 liters, and I will get my concentration. So I want you to do that for both sodium fluoride and calcium nitrate to make sure you get the same concentrations that I do. So for the fluoride ions from NaF, from sodium fluoride, I got 0.167 molar. Keep in mind I'm ignoring the sodium simply because that will not form a precipitate. It's the fluoride ion and the calcium ion. So for the calcium ion, when I redid it, so I took 1.0 times 10 to the negative second, I multiplied that by 0.010 and then divided that by 0.060. Make sure you're getting this because you're going to be required to do this quite a bit in future lessons. I get for my calcium ion a concentration of 0.00167. So what I can do now is calculate my reaction quotient. So Q equals the concentration of calcium ions times the concentration of fluoride ions squared. And so I'm going to plug in the concentrations that I got. So remember, for fluoride it was 0.167 and that needs to be squared. And then times 0.00167. Remember, I don't include calcium fluoride because it's a solid. Okay? And so my Q that I get is 4.65 times 10 to the negative 7th. Well, the KSP I have is 3.9 times 10 to the negative 11th, which means my Q is larger than my KSP. So since my Q is larger than my KSP, I need a shift to the left to decrease its size. So if it's shifting to the left to decrease the value of Q, that means The other type of problem is in which you are given two different ions and you're asked which one is going to precipitate out first. And so that's called selective precipitation, in which you can precipitate out one ion first and then the second ion based on the work we're about to do. So ions can be separated based on the solubilities of their salts, and if we separate them using a reagent that's going to form a precipitate with it, it's called selective precipitation. So if we look at this problem, we're given magnesium ions and copper ions. All right. It asks which ion is going to precipitate out first with hydroxide. So what we need to do is we need to calculate the concentration of OH that's needed to precipitate out each of these cations. And the one that requires the least amount of hydroxide, that's the one that's going to precipitate out first, because as I slowly add hydroxide, one will precipitate out before the other one will. So I'm going to first work with magnesium hydroxide, and there is my dissociation reaction right there, and I'm going to calculate my Q. So I've got my KSP 1.8 times 10 to the negative 11th. That's equal to the concentration of magnesium ions times the concentration of hydroxide squared. And so when I do this, I find that my hydroxide is equal to 1.9 times 10 to the negative 5th. When I do the exact same thing for copper hydroxide and plug that in, what I get for my concentration of hydroxide is 9.8 times 10 to the negative 5th. So copper hydroxide, you need less hydroxide in order to start precipitating out copper hydroxide. So because you need less hydroxide, that means that the copper hydroxide is going to precipitate out before magnesium hydroxide.